basicity will be always basicity will be always true. This is very, very important. Whatever the acid given, you have to take a basicity as to like sulfuric acid, H2SO4. It's a sulfur acid or not? Check this. What do you have? Sulfur. So in sulfuric acid, if you see what is the gram equivalent weight, you can have a gram equivalent weight. Okay. So gram equivalent weight, that is gram molecular weight. Gram molecular weight by 2 you have to take. Gram equivalent weight is equals to gram molecular weight by 2. So here what will be the gram molecular weight of sulfuric acid? It will be 98. 98 by 2. 98 by 2. So sulfuric acid, if you see hydrogen 1 atomic number, atomic weight also, and 2 hydrogens you have, so 2, sulfur 32, 4 oxygens, each oxygen 16, so 4 oxygens you have 64, so 64 plus 32 plus 2. 98 is the gram molecular weight and divided by 2. So next we have here any acid like sulfur, any acid, if you see H2SO3, whatever H2, H2, O7, whatever acid, H2SO5, whatever the acid, here simply gram equivalent weight means gram molecular weight by 2. So here also gram equivalent weight is equals to gram molecular weight by 2. Same story, no change. So sulfur acids, if you see, no worries there. So gram equivalent weight is equals to gram molecular weight by 2. You can take directly. Got it, everyone? So this is the most important thing, sir. Okay. Next, we have the most important thing, that is gram equivalent weight of phosphorus acids. Very much important. Gram equivalent weight of phosphorus acids. So phosphorus acids gram equivalent weights, to understand you must know this skeleton structure. It has a P double bond like this, and you have 3 single bonds like this. So this is the skeleton structure of this most important skeleton structure of phosphorus acid. Okay, so why this is important? If you know this skeleton structure, it will be easy for you. What is that? What will be the basicity? You can understand easily actually. Okay, sir. So now, if you see any phosphorus acid, like I'll consider one here, H3PO2. Okay, so this is hypophosphorus acid. So if you see hypophosphorus acid structure, so P and double bond O is fixed. One P double bond O and 3 single bonds are fixed. So here what I have to mention, so one oxygen has a double bond O you have. So one more oxygen you have like OH. Okay. So here remaining actually total 3 hydrogens, right? So here 1 hydrogen and here 1 hydrogen. So here in this kind of molecule, what will be basicity? Here basicity will be 1 only. Why basicity is 1 here? Because in this, if you see, there is only one OH group, correct? There will be only one OH group. Means how many polar bonds you have? Only one polar bond you have. That means polar bond only can break easily, I told you, because non-polar bonds are equally shared. Equally shared means, can we break them as ions? No, we cannot break them into ions. So if you see OH, there you have a O minus and H plus. So yesterday I told you that, what I said, electronegativity differences. If you know electronegativity differences, so that you can easily say whether the bond is polar or non-polar actually. Got it, sir, everyone? So what I am telling you here, if the electronegativity difference is greater than 1.7, ionic. Electronegativity difference is between 0.6 to 1.7, polar covalent. Then partial positive charge and partial negative charges are possible. Got it, sir, everyone? So it's a very clear thing. When the polarity exists, then only as H plus ion will come out. If the electronegativity difference is less than 0.6, then the bond is non-polar. So you cannot break the atoms into their corresponding ions. This is the most important. So please be careful about this polar and non-polar. So for that, what required? Electronegativity values required. If you know electronegativity values, then okay. Otherwise, just go through electronegativity values which I was given in periodic classification, which is very important, so that you can see that oxygen, I will write here, hydrogen electronegativity is 2.1, oxygen electronegativity 3.5. So the difference you can check here. So difference is greater than 0.6. So between OH, the bond is polar. This bond is polar. So that you can remove as H plus there. But this hydrogen you cannot. As a pH bond, if you see, that is a non-polar. pH. Can you remove H plus here? No. Why? Because phosphorus is 2.1 and that hydrogen also 2. There is no difference actually. Phosphorus slightly more. Phosphorus electronegativity is 2.15 like that. So hydrogen is 2.1 I written, but it's 2.08 like that. So almost similar electronegativity. So H plus cannot come. Why I am explaining this much? pH bond is a non-polar, so that H plus will not come out. So this is the most important. Got it, sir, everyone? And next, I will write the second one. Okay, H3PO3. You can write now skeleton structure. P double bond O and 3 single bonds, right? So that is a skeleton structure. First I am writing. Okay, so one oxygen, you have a P double bond O. So rest are, I will write rest oxygens like this. Okay, so you may think, sir, OH, if you written, that will be over, no, sir, like this. You please write down like this, sir, OH and OH and OH like this. Over, no, sir, then basically 5 valency is more stable. So that's why this particular one is wrong. Which one is wrong? This one is wrong actually. But it's sir. So few people may think like that. If you write 3 OH group, 5 valency, pentavalency is more stable. So that's why we are writing like that. So but it's a so one hydrogen we cannot write with the oxygen. So that's why pH bond exists. So how many OH bonds are there? 2. So here you have one hydrogen and here one hydrogen. That means how many OH groups you have? And this is another OH groups. So OH bond is polar. So H plus will come. It's a clear point. But it's a for this particular pH bond, if you see, that cannot come out as H plus. See this pH bond is non-polar. No. So for H3PO3, what will be the basicity? So here basicity will be 2. For H3PO3, what is the basicity? 2. So if you see now H3PO3, what is the gram equivalent weight means gram molecular weight by 2 you have. Right? But in H3PO2, what is the gram equivalent weight if asked? Gram equivalent weight is equals to gram molecular weight by 1 you have. Got it clearly? So in H3PO2, the gram equivalent weight is gram molecular weight by 1. For H3PO3, gram equivalent weight is equals to gram molecular weight by 2. Got it, sir, everyone? So next, sir, these all phosphorus acids main important, sir. For sulfur acids, no problem we have actually because for phosphorus acids, sorry, for sulfur acids, we don't have any problem. For any sulfur acid, the basicity is 2, so that gram equivalent weight is equals to gram molecular weight by 2 you can write. But whereas phosphorus acids, if you see, that depends on the structure. Okay, so how many OH groups you have, those many hydrogens can come out. This is the most important clear note. Okay, so if you see one more like H3PO4, orthophosphoric acid. Orthophosphoric acid. Previous one I written no, that is orthophosphorus acid. If you have any doubt, you can ask me and don't bother. Okay, so if you see the structure of this, same story. You have a 3 double bond O and you have 3 single bonds. Now, how many oxygens you have in H3PO4? 4 oxygens. So, one oxygen has P double bond O, that is fixed. We cannot change that one. So, remaining 3 oxygens you have like this. So, this is like one OH and this is another OH. This is one OH. This is the structure of H3PO4. So, here if you see, what are the number of OH groups? 3 OH groups. Certainly, what will be the basicity here? Here, the basicity is 3 here. So, for this H3PO4 orthophosphoric acid, what will be the gram equivalent weight? It will be gram molecular weight by 3. Of course, this one also 98. 98 by 3 you have. This is the gram equivalent weight of what? Acids. Okay, any acid. Yesterday I was given CH3COOH. So there also one H plus ion can come out. But it's everyone. So I told you reason also. 3 hydrogens in CH3COOH. I written like this. Fourth example. CH3COOH. Some disturbance we had yesterday in class. So that's why I'm writing again. So here 3 hydrogens what you have are non-polar. Only this hydrogen is a polar. So that H plus can come out. This one only can come out as H plus. Okay, these 3 hydrogens cannot come out as H plus because carbon electronegativity is 2.5. Hydrogen electronegativity 2.1. So the electronegativity difference is how much? 0.4. So less than 0.6. So the bond is non-polar. Bond is non-polar, so that you cannot remove H plus. So even 4 hydrogens are there in CH3COOH. The basicity cannot be 4. The basicity is 1. So 1 hydrogen is directly attached to oxygen. So 1 hydrogen is polar and the rest of 3 hydrogens are non-polar. So the gram equivalent weight of this particular acetic acid, CH3COOH, it will be 60 by 1 iron. So few are exceptional cases like this. So please make sure what all of this. Okay. Okay. Next we have electronegativity values. Please go through that. And gram equivalent weight of bases we have. Gram equivalent weight of bases. So if you see gram equivalent weight of base, I said in previous also, gram equivalent weight of base is equals to gram molecular weight by acidity. This I was given, so I corrected also this one yesterday. So what is the acidity here? This is the question for us. So acidity, following sir, acidity means number of hydroxy groups, means OH minus ions present, you can say this time, because oxygen is a more electronegative atom, second most electronegative atom. Highest is fluorine. Next electronegative atom is oxygen. So oxygen is always polar. So how many OH groups are present? That is equal to acidity in any base. Okay. So number of OH minus ions present in any particular base, that is called acidity. So what is acidity? We have clarity. So what is the gram equivalent weight means for what? For base. Gram equivalent weight of a base is equals to gram molecular weight by acidity. Got it, sir, everyone? So acidity means I given clearly here the number of OH minus ions. Number of OH minus ions present. That is what? Acidity. Got it, sir, clearly? Now I'll give some example. Here no exceptional cases. How many OH groups are there? That is equal to acidity. So simple, I'll give few examples like this, like sodium hydroxide, if you can see. Sodium hydroxide. Okay. What is the gram equivalent weight? Gram equivalent weight is equals to gram molecular weight. Sodium 23, oxygen 16, hydrogen 1. Sodium 23 atomic weight, oxygen 16, hydrogen 1. So it's 40 by 1. That's it. Clear? So NaOH gram equivalent weight is equals to 40 by 1. Clear, sir? Okay. Why? How many OH groups you have? Only one. So NaOH, the gram equivalent weight is 40 by 1. Like that. Any particular you can take, like MgOH plus. You can check this. So what will be the gram equivalent weight means? By 2. First I write that divided by 2. Why? There are two OH groups. Okay, there are two OH. Certainly you have acidity too. So here the gram equivalent weight, you can have gram molecular weight. If you want gram molecular weight, magnesium 24, oxygen 2 oxygens are there, so 32 and 2 hydrogens 2. 24 plus 32 plus 2. Okay, this is the gram molecular weight by 2. Okay. Yeah, next, if you can see like aluminum hydroxide, AlOH price, if you see, then the gram equivalent weight is equals to same story, gram molecular weight by 3 you can. But it's very clear. Next, we have some gram equivalent weight salts. Okay, so those we will discuss now. Gram equivalent weights of particular salts. Gram equivalent weight of salts, very simple. Gram equivalent weight is equals to gram molecular weight by either charge. What charge? Charge on cation, or else anion. This is a gram equivalent weight of particular salt. So gram molecular weight by charge on cation or else charge on anion to consider. Yesterday itself I told you what charge we will consider. No need to bother about the class yesterday what happened, but today if you listen carefully you can understand, because today I am giving all examples, right? So if you see charge means you have no need to consider sign. Okay, you have to consider only particular number. If -2 is there, what's the number there? 2. So that will be the valency. Okay, so here you have to write total charge. That's better actually. Total charge on cation or anion, if you write, that's better. Because in some salts you have 2 cations. In some salts you have 2 anions. Not only 2, maybe 3, 4 like that. At that time, you have to consider total charge of all cations and total charge of all anions. So any charge you can consider either positive charge or negative charge, but in the denominator don't substitute that particular charge. Positive, okay, no problem. If SO4 minus 2, if you substitute minus 2 in the denominator, the weight will be negative. Will the weight be negative possibility? No, not at all, right? Negative charge is not at all possible for weights, particularly for these particular chemical substances. Got it, sir? So if you see some examples like NaCl, see, you can dissociate these as Na plus and Cl minus, right? This is the first example. So here, what will be the gram equivalent weight means simply gram molecular weight by 1. Few people are very smart. What they say, sir, sodium plus 1 and chlorine minus 1. Plus 1 minus 1, 0, sir. In the denominator 0 you will take, then the total will be infinity. Okay, any charge, either cation charge or anion charge. As I said, this chlorine has a minus 1. Don't substitute minus 1 here. 1. Okay, so gram molecular weight of NaCl, it will be 23, sodium 23, this chlorine 35. So 58.551. Why is it 8.5 understood? Sodium is at 23 and a chlorine 35.5. So like that you can consider, right? So next, if you see like Na2CO3. Na2CO3, a gram equivalent weight. First, I will write valence factor, which is 2. Sir, why the valency factor is 2 means here you can write 2 Na plus and CO3 minus 2. This is a charge separation. See, in NaCl there is a 1 sodium, right? Then one ion charge you will consider plus 1. But in Na2CO3 you have 2 ions. 1 sodium means plus 1 you will take, and 2 sodiums means plus 2 you have to take. Correct? And the same, whatever the total charge you have for a cation, the same charge and which is opposite you have for anion. But clearly, suppose if the cation charge is plus X and the anion charge is minus X, that's it. Okay, no difference because salt is a neutral. So there won't be a negative, there won't be a positive. Okay, so here you can write it is 106. 106 by 2. This is the gram equivalent weight of Mr. Who is that? Salt. For salt, the gram equivalent weight is equals to gram molecular weight by total charge on cation, or suppose third example I'll take Al2 SO4 thrice. Okay, so here how to separate this? 2Al plus 3 and sulfate PSO4 minus 2. This is the charge separation. See, Al2, here 2 you have, right? Here you have 2, right? The 2 is the charge of sulfate and this 3 is the charge of aluminum. Please. Okay, how to remember? Otherwise, some ions I will keep, don't worry. This 3 is the charge of plus 3 is the charge of aluminum and 2 is the charge of sulfate. So here what will be the gram equivalent weight? Gram equivalent weight means here the gram molecular weight by Mr. Al2SO4 plus. Total gram molecular weight you have to calculate. Aluminum atomic weight is 27, sulfur 32 and oxygen 16. But all atoms weight you have to write here as a gram molecular weight. And in the denominator I have to take 6. Why? 1 aluminum means plus 3. Correct? And 2 aluminum means 2 3s are 6. Okay? Understanding everyone? Same way. 3 into -2, -6. But don't take negative charge, I told you already. So 3 2s are 6. That's it we have here. The gram equivalent weight is equals to gram molecular weight by 6 we have taken for Al plus 4 times. That's what I said. Total charge we have to consider. Got it clearly? So Al2SO4 thrice is like this we have to consider. So okay, any particular given like calcium carbonate, Ca plus 2 and CO3 minus 2. Ca, CO3. So what the charge separation? Calcium which group? 2A group. Means plus 2 no charge. Like that. Charge or why aluminium plus 3 don't ask me. Okay, aluminium third A is plus 3. What is that? What is that everyone? And only one calcium here. And carbonate CO3 minus. Some cations and anion charges I was explained in redox reactions chapter. Oxidation state concept also I am telling. Please revise that concept so that it will be easy for you. My request and order. You please check the charges of all cations and anions clearly. Correct, sir? So CaCO3, if you see what will be the gram equivalent weight, that is 100 by 2. So here you written gram molecular weight 100, but here why you not written gram molecular weight means it was not calculated for Al2SO4 plus. So that's why I written gram molecular weight because it's somewhat big. So that's why I was not written. So if you want, I can write like this, like what aluminium 27, okay, and sulfur 32, and oxygen 16. So all I can take here 2 aluminiums. So into 2 sulfur 3 you have because SO4 thrice no. So into 3 here 16. But into 16 into 12 I have taken. You know why? O4. Okay, whole thrice. 4 3 is 12. So 16 only. Total you have to add as Al plus O4 thrice. Got it, sir, clearly? So this is about a gram equivalent weight of particular cell. This is the most important thing, and this is the new for everyone. It's a new concept for every student. Okay, till now you may have some idea previously, but this is completely new. So what is that? Gram equivalent weight of oxidants and reductants. The most important concept. So here you must have one idea, oxidant or oxidizing agent. Oxidant means undergo reduction and oxidize others. Oxidize others, the most important. So oxidant or else, as I said, oxidizing agent you can write. So undergo reduction and oxidize other. Reduction means what? Gain of electrons. Correct? Huh? Oxidize others means others will oxidize, and who is acting as oxidizing agent, who is oxidizing agent otherwise, that will undergo reduction. So opposite reaction actually. Okay, oxidant or oxidizing agent undergo reduction and oxidize others. Okay, X is a oxidizing agent and Y is a reacting with X. So X is oxidizing agent. So X will undergo reduction. Who is oxidizing agent? X. So that X will gain electron. Okay, by undergoing reduction. Y what happened? Lose electron. Y undergoing reduction. So when some X reacting with Y, X is the oxidizing agent, so that X will undergo reduction by gaining of electron. Clear? Okay. So oxidant means that's it. Who are undergoing reduction and oxidize others. So for oxidant to have gram equivalent weight, what we have to take? Tell me. Gram equivalent weight of C. OC. Cannot say it right now. Generally, I'm asking. Maybe you can answer for yourself. Gram equivalent weight of oxidant, you can say, is gram molecular weight by oxidant undergoing reduction. No, reduction means gain of electrons. No, so you have sorry, number of electrons gained. This is a gram equivalent. Gram equivalent. Please have a look this one. So slowly understand. No problem. Don't worry about time. So gram weight of oxidant is equals to molecular weight by number of electrons gained. This is the most important. Okay. So first I am talking about oxidant. So gram equivalent weight of oxidant. The same you can have for reductant, right? I'll write that only now. Okay. So what is the reductant? Reductant means which undergo had all these in redox reaction chapter. Got it? So, but once again, I'm just recapping all these things. Reductant means which undergo oxidation, sir. Which undergo oxidation, the most important. See, ultra reaction, I told you, as I said, oxidant undergoing reduction and reactant undergoing oxidation. What is it? And reduce first. Okay. So, what is the process of oxidation? I told you already. Oxidation means loss of electron, right? Oxidation means loss of. These things are very, very important. I'll highlight those. Oxidant undergoing reduction. Reduction means gain of electron. So here reductant means undergoing oxidation by loss of electron. These are the most important. And this one also gram equivalent weight of oxidant also very important. Electrons gained. Okay. So now I will write the gram equivalent. Okay. So you can guess now. Gram molecular weight by number of electrons gained I written for oxidant. So here what I write gram equivalent weight of reductant because during the process of oxidation lots of electron takes place, right? So these two are very, very important. So the gram equivalent weight of oxidant and reductant we have here. Okay, we have here. So the gram equivalent weight of oxidant and gram equivalent weight of reductant. So as I said in previous, so gram equivalent weight of reductant, if you see, this is a gram molecular weight by number of electrons lost. Loss I written, lost you can write. Got it, sir? So next, I'll give examples. Half of our headache over now. So these two formulas are very important. What are those? This one. Gram equivalent weight of oxidant and gram equivalent weight of reductant formulas are very, very important for us. Okay. I'll write some examples now. The most important example I'll write first. Gram equivalent weight of KMnO. This is the most important. In different mediums, we have this. The reaction is different. See, loss of electron or gain of electron is happening, right? Okay. Loss of electron or gain of electron is happening. Okay? That happens in a medium actually. Loss of electron or gain of electron. So medium is important. And that's why in different mediums I'll explain. because different numbers may be lost or gained in that particular, depends on medium actually. Okay, in a particular medium actually. Okay, so gram equivalent weight of KMnO4 in acidic medium. First we will discuss. Gram equivalent weight of KMnO4 in acidic medium. So first what happens, this KMnO4, I'll write like this. No change in oxidation state of K plus. Okay, why? Told you already, K plus is an alkali metal. Alkali metals and alkaline earth metals always have a fixed oxidation states. So no change in oxidation state of K plus. Okay, so potassium always plus one. Sodium, lithium, whatever you have in alkali metals, lithium, sodium, potassium, rubidium, cesium, all have a plus one always. Beryllium, magnesium, calcium, strontium, barium, always plus 2. Alkali metal, if you ask, you are mad. Okay, so don't ask me that kind of question, please. Alkali metals always plus 2. But it's clearly. So now we have a gram equivalent weight of K1 for an acidic medium. So whose oxidation state will change? Minus 2 always. So whose oxidation state will change means manganese. How it will change in a acidic medium? Acidic medium means, correct? Acidic medium means acid, like H2SO4 presence or HNO3 presence. We will have this reaction. So MnO4 minus, it converts to manganese plus 2. Manganese plus 2. On arrow, I am writing H plus. Why I am writing H plus? This happening in acidic medium. So this is the representation of acidic medium. What is that? This particular. H plus why I written in acidic medium. That's the meaning. Now, what is the change in oxidation state? If you see this manganese, whose oxidation state is changing here? Manganese. Manganese is X. X plus 4 into minus 2 is equal to minus 2. Do you know the calculation of oxidation states? I told you already. So here manganese oxidation state only change. Okay. So here manganese oxidation state previously, how much I have to calculate. Okay. So X equal to plus 7. So here manganese plus 2 only. So its oxidation state is plus 2. So plus 7 converted to plus 2. That means how many electron transport? How many electron transport? 5 electron transport. 5 electron. How you said sir 5 electron transport? Because you can see that. You can see there oxidation state how changing from plus 7 to plus 2. So plus 7. Alright. Plus 7 converted to plus 2. Plus 7 converted to plus 2 means is it oxidation or reduction? Oxidation state reduced or increased? Reduced. Reduced or not? Gain of electrons. So to have add oxidation state reduced. Oxidation state reduced from plus 7 to plus 2. Suddenly what happened? Number of electrons what happened? Gained. How many electrons gained? 5 electrons. 1 electron means what is the charge? Minus 1. So 5 electrons means what is the charge? Minus 5. So 7 minus 5. 7 minus 5. So that means oxidation state changes from plus 7 how many electrons? Sorry for that. This means you must know clarity. Okay, how many electrons are transferring during conversion of MnO4 minus to Mn plus 2 in acidic medium? Got it, sir, clearly? So now in acidic medium, they will ask you what is the gram equivalent weight of KMnO4. So now the gram equivalent weight of KMnO4 by H plus. By H plus means what is the meaning? In acidic medium, you can have now 158. So how you written for 158 number means, sorry, it's a joke. 158 is not a lucky number. 158 is the gram molecular weight. 158 is the gram molecular weight. Okay. So gram molecular weight of whom? KMnO4. Okay. So next, same gram equivalent weight of KMnO4 in neutral medium. Neutral medium means everybody knows, right? Like water, okay, or else some organic solvents like CCl4. There, KMnO4, I'll write only MnO4 minus. Why? I told you already, man. The K plus won't change; it remains fixed. So here, manganese plus 7 converted to MnO4, here MnO2, manganese plus 4 actually. Mn plus 4 actually. So here manganese oxidation state is plus 7. Here the manganese oxidation state is plus 4. That means how many electron transfer? 3 electron transfer. Sir, why sir manganese plus 7 converted to manganese plus 4? You may have a question, but that reaction happens like that and the conversion happened in neutral medium. We can't do anything. Okay, that's a reaction. Chemical reaction happened like that. That change happened. What I can do? Okay, so MnO4 minus, it converted to MnO2 actually. So MnO4 minus means manganese plus 7. MnO2, sorry, yeah, MnO2 means manganese plus 4 because each oxygen minus 2, no? So 2 oxygens are there, so minus 4. Certainly manganese oxidation state will be plus 4. Got it, sir, clearly? So here how many electron transport means 3 electrons. Just change in oxidation state, that's it. That will be the valency factor for this particular KMnO4. KMnO4, if you see that undergone reduction means KMnO4 is oxidant. Got it, sir, clearly? So one more we have last. Therefore, gram equivalent weight is equals to gram molecular weight by Cu. Last and final. Okay, so this is gram equivalent weight of whom? KMnO4. Okay, so you can have this as 158 by 3. Last and final. Gram equivalent weight of same KMnO4 in basic medium. See this neutral medium I said, no? Neutral medium or weak alkali. Weak alkali means basic. What is that, everyone? Now we have to discuss the gram equivalent weight of KMnO4 in what medium? In strong alkali. Strong alkali. Alkali means what is the meaning? Basic medium. Basic medium. So the gram equivalent weight of KMnO4 in strong alkali medium, you can see your MnO4 minus, it converts to MnO4 minus 2 actually. Got it, sir, clearly? So here you have a manganese oxidation state. Here manganese oxidation state is plus 7 in MnO4 minus. Here manganese oxidation state is plus 6. Plus 7 converted to plus 6. So 1 electron transport. Therefore, the gram equivalent weight is equals to 158 by 1. Because plus 7 converted to plus 6. Therefore, here 158 by 100. So finally, we had one conclusion here, how to calculate gram equivalent weight of oxidants. Okay, and tomorrow we have few more examples based on this gram equivalent weights. Okay, thank you very much.